Hi, I'm going to go over some calculations that should help you with your kinetics of a clock reaction lab. So the first thing that we want to do is figure out what the actual concentrations are of the chemicals that we used in the reaction. So starting off with our sodium thiosulfate, we have a stock solution of 0.001 molar. However, you didn't actually use this in your reaction because you took 10 milliliters of this and you put it into a 50 milliliter total reaction. So in order to figure out what the actual concentration is in the reaction vessel itself, we want to use our lovely concentration 1 volume 1 equals concentration 2 volume 2. And we know that our concentration 1 is 0.001 because we got it off of our bottle. We know our volume 1 is 10 milliliters. And we know our volume 2 is 50 milliliters. So we're going to solve for concentration 2. So we have 0.001 times 10 divided by 50. You don't need to convert the milliliters to liters because these are in milliliters here and these are in milliliters here, so those units cancel. And so what we get is a concentration of 0.002 molar. So now that we know the concentration of this, we can start to calculate our rate. So if you look at the handout, equation 11 tells you that the rate is the initial concentration of the thiosulfate ion divided by 6 times the time in seconds. So if we were to write that out, we would write rate equals, and then you could do this, 3, and then 6 times time. So for example, let's say that one of our reactions was 146 seconds. We multiply this by 6, we get 876. We take our concentration of 0.0002 divided by 876, and we get 2.283 times 10 to the minus 7th. So now that we know how to find the rate, we want to compare the rates of different reactions so that we can figure out what the order is with respect to each of the reagents. So if we take a look at our data here, so here we have our different trials and we have our concentrations of our reagents here and the time in seconds. And so remember that the rate is really this number here divided by 6 times the time in seconds. And so we calculated this on the previous page. And so what you want to do is take a look at how these reactions are different from each other. So for example, if we look at C1, we see that we have the iodide, the bromate, and the hydrogen ion concentrations. So if we want to figure out what the rate is, what the order is with respect to bromate, for example, we need to compare two reactions where only the bromate ion concentration changes. So if we look at comparing C1 and C2, we see that iodide is constant, hydrogen is constant, the hydrogen ion is constant, and then we see a change here with the bromate. So we've doubled the concentration of bromate. So we can compare C1 and C2 in order to find the order with respect to bromate. So we're going to need to know the rate of this one too. So let's go ahead and do that. So we have our 0.0002 divided by 6 times our time in seconds is 84, and this is going to equal 3.968 times 10 to the minus 7th. Okay. So what do we do? Well, we could go ahead and create ratios of all these, but we know that the concentrations of these don't change. Of this doesn't change and this doesn't change, so that doesn't really matter. So we're just going to focus on our bromate and compare the rate and how it changes. So if this doubles, how does the rate get impacted? And so we can compare these numbers. Now, if you're struggling with the times 10 to the minus 7th, Notice that they're both times 10 to the minus 7th, so you kind of just ignore that part and just compare these two numbers to each other. And what do you see? So if we take we make a nice little ratio here. So let's do 3.968 divided by 2.283, and that's 1.7. So we want to round up or round down as appropriate. So 1.7, that would round to 2. So it's about 2 times. So what happened here? We have a doubling of this concentration, and we have a doubling of the rate. So that would mean that this reaction is first order with respect to bromate. So if we wanted to write out our rate law, where we have our rate equals, and we have our I to the M, our BrO3 to the N, and our hydrogen ion to the P, then that would mean our N would equal 1. Because as we double the concentration, we've doubled the rate, therefore it is first order with respect to bromate. So now you should be able to do something similar for the other 2 reagents. So you want to figure out which reactions you want to compare to calculate M, which is the order for I minus, and then you want to figure out which reactions to compare, which 2 sets of reactions to compare to get the order with respect to H plus or P.